What's up to the people who took the time out of their schedule to watch this video? I hope it is worth your time. The magic flat earth, the equator. Now, this is going to comprise of a couple of videos just showing how on any possible flat earth model that the equator would have to be magical based on what we see and observe in the celestial sphere. The first thing is I want to touch on is the equator divides apparent celestial motion into clockwise and counterclockwise rotation. Why is that? Now let's look at a photo of the equator looking into the sky at nighttime, taking a time lapse of the apparent motion of the stars. They appear to virtually go in a straight arc line at the equator. The globe easily explains why this would happen, right? The globe easily explains why this would happen. If you're here on the equator, then you would expect to, let's move it over here a little bit. You would expect that if you were somewhere around where my cursor is that if you were looking up at the sky at night, that the star trails would appear to be coming from the east to the west in a virtual straight line. So that's understood on a globe. But how about a flat earth? Why would it do that on a flat earth? For what reason? A stationary flat earth, why would they appear to rotate virtually at the same amount of degrees throughout the night? The stars I'm referring to appear to rotate at virtually the same amount of degrees, 15 degrees an hour, and you're on a stationary flat earth. Any possible flat earth model you can come up with, pretty much besides like a Google Maps style flat earth with a Pac-Man sun and star trails, etc. Outside of something like that, there's no reason at the equator where the star trails should appear in a straight arc, not curving north or south directly 90 degrees above the equator, but going 90 degrees to 270. A 180 degree trail. Okay, and let's just back up on the equator, get a wider view. So at the equator, it appears to be like a dividing line. It's straight at the equator, but then when you look, if you're looking east and you look to your right, you see the trails begin to arc from south. And if you look in the north, the trails appear to arc from a northerly direction. So the equator appears to be some type of magical dividing line for a stationary flat earth. If you look north, the north stars appear to they rotate counterclockwise. And in the southern hemisphere, they appear to rotate clockwise. Why would that happen on a flat earth and the equator be the dividing line? That's my focus, the equator. I'm not dealing with the celestial poles yet, but the equator is the dividing line. Why? I would like, if you can, flat earthers, to give me an answer to that. A logical answer. Not something that you say makes common sense. A lot of flat earthers like to say and use the term common sense. And then right after saying that, they speak something that's nonsense. I don't get it. The second thing I want to speak of dealing with this, the star trails is, or the stars, it divides, the equator divides the visibility of the celestial pole. Why is that? When you go 1 degree south, you can no longer see the north celestial pole. And you go 1 degree or 69 miles north, you no longer see the south celestial pole or point. Why is that? On a flat earth. Just say if I'm at the equator here and I'm looking at the North Star, Polaris. Let's say I'm looking at Polaris. It should be a measure of degrees above my vision. However, it's at 0 degrees. It looks like it's right there on the horizon. What sense does that make on the flat earth? It doesn't make any sense. But all you can spew is nonsense. If I step back a little bit from the equator, I step south, or I go a degree south, for some reason, that star that should be up here somewhere is now no longer able to be seen. Where's the limits of your vision? Man, cut the nonsense. And then if I go and I turn south from the equator, Sigma Octantis, if I'm able to see it, if it's bright enough, or just let's just say this represents the south celestial pole, that should be up here somewhere, it appears to be on the horizon. Doesn't make any sense. But then if I step or go back 69 miles north, I no longer see the south celestial pole. Come on, you got to make it make some kind of sense, man. See, the globe easily would explain this if you're near the equator. I know it's not 100% accurate, but it's just giving you a picture or a representation. The Earth is tilted at 23.5 degrees to the plane of its orbit. And we would expect this at the equator. We would expect the north celestial pole to be at the horizon and the south celestial pole to be at the horizon from the equator. This is what we would expect on a globe, right? And that equator being the dividing line, hold on, let me make this a little bit smaller. That equator being the dividing line, if the Earth is rotating from west to east and we're looking north, then the sky would appear to be going counterclockwise, right? The sky, if I'm looking north and I'm in the northern hemisphere, the sky would go to or from my right to my left. But it will meet at a point, understood, it will meet at a point somewhere above the axis of rotation. So I would expect to see a celestial pole or point that's going from my right to my left if I'm looking north of an Earth that's rotating from west to east. And vice versa, if I'm looking south, then even though, as some flat earthers say, all you got to do is turn around and you should see it going in a different direction, or it's going in the same direction, but from your vantage point, it's going in a different direction. That's true. But the problem is, it's not just appear to be going in a different direction, even though the star trails are coming from the east or appear to be coming from the east. but it's also going around a central point that we call the south celestial pole. That's what makes it a problem. So it ain't just about changing your direction and looking in a different direction. If I go far south and if I go 60 degrees south, or let's say in Ushuaia, 54 degrees south latitude, and I look up 54 degrees in the from the horizon, then that's where the south celestial pole will be if I'm looking due south. And that's what you would expect on a globe. But the point is that the equator is the dividing line. Could you answer that question? Why? And how could that work on a flat earth? Any possible flat earth model. Flat earthers, there's a reason why you don't have a working model. Let me see you use your common sense. I'll talk to you next time.